Three sound waves of equal amplitudes have frequencies n minus 1, number 1 frequency, n minus 1, next frequency is n, another frequency is n plus 1. They superimpose to give beats. The number of beats produced per second will be the maximum number of beats, maximum number of beats is equal to modulus of n plus 1 minus of n minus 1. So n plus 1 minus n plus 1, n gets cancelled, that is equal to 2. The maximum number of beats is 2. Option is second. This is our answer. An air column closed at one end and open at other end resonates with a tuning fork when the smallest length of the column is 50 centimeter. The next larger length of the column resonating with the same tuning fork. This is a closed pipe. A resonance operator. Closed pipe frequency ratio, that is n1 is to so n3 or is to 3 dash is equal to 1 is to 3 is to 5. In the similar way, length also, first L1 is equal to where lambda by 4, and next L2 is equal to 3 lambda by 4, means lambda by 4 value is L1, therefore L2 is equal to 3L1. But given the before length L1 value is given 50 centimeter, therefore 3 into 50 is equal to 150 centimeter. This is the our question. The next largest length of the air column resonating with the same tuning fork is, that is L2. L2 is equal to 150 centimeter. Therefore third option is the correct answer. A siren emitting a sound of frequency 800 Hz moves away from an observer towards a cliff at a speed of 15 meters per second. Then the frequency of sound that the observer hears in the echo reflected from the cliff echo, and the velocity of the sound is 330 meters per second. From the question, the actual frequency is n is equal to 800 Hz and source velocity is 15 meter per second. Away from the cliff, n dash is equal to how much? So away, n dash is equal to n into v by v minus vs. So n dash is equal to echo is the reaches, the reflected wave is reaches to the observer, therefore frequency I can write that is v minus vs. Therefore n dash is equal to n is 800, v value is given 330 by 330 minus vs value is the 15. So n dash is equal to 800 into 330 divided by 3. The fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe. If the length of the closed pipe is 20 centimeter, the length of the open organ pipe is. So the given data is, if the length of the closed organ pipe LC is equal to 20 centimeters, The length of the open pipe LO is equal to how much? And the fundamental frequency of an open argon pipe is equal to, fundamental frequency of open argon pipe is V by 2L is equal to the third harmonic of closed argon pipe, means 3V by 4L. This is the open pipe LO, this is a closed pipe LC. So in which the VV gets cancelled, 2 1 ja, 2 2 ja. So therefore L naught is equal to 2LC by 3. 2 into LC value 20 by 3 means 40 by 3. 40 by 3, 3 1 ja, 3 3 ja, 0.33 centimeters. So the first option is the correct answer. Question A. Source of frequency 340 Hz. 340 that is N is equal to 340. Vertical cylinder tube closed at lower end, means this is a closed pipe. The length of the tube is, total length L is equal to 120 centimeters, means 1.2 meters. Water is slowly poured in just enough to produce resonance. Then the minimum height H is equal to how much? Minimum height of the water level in the tube for that resonance is, and also the velocity of sound is equal to 340 meter per second. And in the closed pipe the frequency ratio is that is N1 is N2 is N3 dash dash is equal to 1 is 3 is 5 is and so on. And the height, so do you want the total length of the pipe is L and height, do you want height H is equal to total length minus third frequency ratio 3L1. So but L1 is find from the fundamental frequency in closed pipe, N is equal to V by 4L1. So in which L1 is equal to V by 4N. V value 340 and 4 into N value also 340. 340 gets cancelled. So we get 1 by 4. 1 by 4 means 0.25 meters. So our determination is H. Therefore H is equal to L value is the 1.2 and 3 into L1 value is 0.25. Therefore 1.2 minus 0.75. 1.2 minus 0.25, so 0.45. This is the answer. The fourth option is correct. An air column in a pipe that is closed at one end is in resonance with a vibrating tuning fork of frequency 264 Hz. Length of air column is, so the given frequency N is equal to 264 Hz and determine the length. This is the closed pipe is equal to how much, and the velocity of the sound is given by 340 meter per second. So, and the fundamental frequency of closed pipe N is equal to V by 4L, means closed pipe LC. So calculate LC. LC is equal to V by 4N. So the V value is 340 divided by 4 into N value 264. 4 into 6 LC is equal to 340 divided by 4 into 264, 16, 1056. That is equal to 0.321 meters. The question in centimeter, therefore 32.1 centimeter. This is LC. So first option is the correct answer. A tuning fork is used to produce resonance in a glass tube. The length of the air column in the tube can be adjusted by a variable piston. At room temperature of 27 degrees centigrade, two successive resonances are produced at 20 centimeter. L1 is equal to 20 centimeter and L2 is equal to 73 centimeter. The frequency of the tuning fork N is equal to 320 hertz and the velocity of the sound at 27 degrees centigrade. Same temperature, the velocity of the sound is calculated. So our formula velocity of sound at resonances 2 resonances 2n into L2 minus L1. So E is equal to 2 into N value is 320, L2 value is 73 minus 20 in centimeters, therefore you should write into 10 power minus 2 meter. Okay, V is equal to, this is a 640 into 73 minus 20, 53 into 10 power minus 2. Therefore 640 into 53, 33920 into 10 power minus 2. The velocity V is equal to 339.2 meter per second. This is the answer. Our second option is correct answer.